Welcome back to the hyperbolic coding chamber. We are back once again. More suffering to be had with a great question to pose. The question is, should we stream? I think that's the real question. I think it could be a nice addition. I think there's just not a huge space for the long form LC content, and I think the way that this channel works is probably better for streaming, but I realize that the daily videos doesn't really give me a chance to put effort towards other things, because I do like an hour of LeetCode and then an hour I've been doing like 4 hours of game dev, so I've been sleeping really late, and yeah, that's how that's kind of been going. So leaves a little to be desired, and I keep thinking I'm gonna make higher effort content, but I just never get around to it. So maybe streaming is the wave. So a lot to think about there, but I figured I would pose the question. Maybe it could be the wave. So maybe that's what we'll do. I think I might try and start with some game dev first, but we shall see. Maybe we'll do both. Maybe we just do both live. It would just two birds with one stone, and we'd guarantee a 2-hour stream every day. That might actually be torture. It might actually be torture. So we shall see. Maybe that's a better wave, and then we can just post the video afterwards. But I think that would be ideal. That would be pretty dope. So maybe it could be flames. Maybe it could not be flames. But we do have a comment, so I think we should check it out today, and it's by the one and only, the legendary philosophizer themselves, ADC, Skateboard Steez Master Supreme. You got this finger emoji. Do it for Messi. We got to do it for Messi. So there are no greater words to be said than that, no greater reflection. So yeah, we got to do it for Messi. So we're sending our spirit energy, and yeah, so the LeetCode grind has been going well. Fortunately, the 1 hour a day is actually giving us some pretty good results. So I think if we continue at this rate, we should see some pretty good results. But I think it would just be much cooler if we could just spend a greater amount of time getting this over with. But unfortunately, or fortunately, we have to work. Maybe we need some suffering. But yeah, I think it kind of feels like I could be ready to just spend like 6 hours a day on this, but gotta pay the bills somehow, so it'd be like that. So maybe we'll figure out a way. So that could be cool. But I do feel like we could be ready. But the LeetCode grind is progressing well. I think if we refresh up here, I think my camera is blocking it, but I'll zoom in. We are at 256 problems completed, which I think is almost slightly more than, I was going to say it's 10%. It's 9.8%. So, man, it would be legendary if we could get, 10% would have been dope. But I think next year we'll have all the problems done. I'm going to keep it a stack 1,000, okay? I think next year we'll have all the problems done. In 2 years, we'll be unstoppable. 365 days from now, the journey will be complete, and we'll have done it, and it'll be pretty epic. So yeah, 256 is crazy. $256 is actually crazy. So damn, I wish it was 10%, but 10, it's close enough. I think if we keep moving, we'll get there. I think once we get, I'm going from the hardest to easiest. So we're starting with the easies first, because the hard, we might spend maybe 2 weeks on all 500 hards, maybe, if that. So that's why we're going this direction, but we're almost 1/3 done with all the easies. So that is exciting. So hopefully we can plow through some problems. I have to definitely say that the problems are getting easier. So when we first started the easies, it was like, we were taking times, but now I definitely feel like we're getting pretty saucy with the TypeScript. So it could be complete soon. We might be on our Shigaraki, and the carcass, the complete body may be ready soon, and we might just have to reach 100% power yet. So maybe it's a Mob Psycho type beat where we're 9.8% close to explosion. So the LeetCode Grandmasters are still constantly messaging me. They're telling me to stop. You can't do the problems this quickly. No one's ever done them this fast, and I just got to tell them that we're just going to keep going. So unfortunately, the writing is on the door, and the LeetCode Grandmasters are afraid. So we can't stop here. So I think we're going to have to continue, and we're going to do another hour session, and I'll be right back. So we're going to do an hour as per usual, and then yeah, we'll just make sure that we keep making progress. So we're going to do an hour and continue to slash down technical debt. So we did quite a few different problems yesterday. I just realized we never finished this problem, which we started a long time ago. But I'm going to queue up a couple of more problems. We'll add special array with X elements, leaf similar trees, divisor game, last stone weight which we're on, and replace all question marks. Partition array into 3 parts and find resultant. So we're on something with last stone. So you are given an array of integers, stones, where stone sub I is the weight of the ith stone. We are playing a game with the stones. On each turn, we choose the heaviest 2 stones and smash them together. Suppose the heaviest 2 stones have weights x and y, with x less than or equal y. The result of this smash is, if x is equal to y, both stones are destroyed. If x does not equal y, the stone... I remember why we didn't finish this problem. I said I wanted to come back when I could implement a heap. And I think we're still reading a combinatorics chapter. I think we can solve it without it though, but... I think this should fix the problem. So ending up with 0, which means this is proccing when it shouldn't be proccing. And then we just make sure that they can't have the same index. Oh. Our output is 3. The expected was 2. Wait, we should use the two heaviest stones. So if stone sub first max IDX is less than stone sub M, then first max IDX is equal to M. How are we getting the largest element by doing that? Oh right, if we're holding a smaller element, then we become that element. So if we check in here, we should end up with indexes 3 and 1. They aren't the same, and the index aren't the same. Should we do stones first max, which would be 3, minus stone sub second max, and then stone sub second max would equal 0. Then from here, we'd look through the array and pretty much return the stone that is remaining. So for some reason, if we print console.log stones here, yeah, we have 3, 1 still, which doesn't make any sense. So I'm wondering if both of these indexes are coming up with the same value. What does stone sub... Oh, they both start at index 0. M does not equal first max of IDX, and stone sub second max IDX is less than or equal to stone sub M. 3 is not less than 1. Since we're looking for the largest possible value, they both start at 0, which is kind of an issue. I think it might be easier if we just start this one at -1, and we'll say that it can't equal to, we can't be equal to first max IDX, right? And it should be less than it, or second max IDX equals -1. Then I think if we add this to our test case, I think we should be okay. They both don't equal. I'm wondering if it's going to force me to make the first. So we don't have to do the first one. This is a little messy though, and this problem is very ghetto. It's basically would be n squared time. N squared time with constants, or technically we're reusing the array. So stone sub second sub max gets sets to equal 0 anyway, so we can remove this whole if statement if we just check that first max idx should get the value of if stone sub first max idx equals stone sub second max idx, then it should get the value of 0. Otherwise, it should get the value of stone sub first max idx minus stone sub second max idx. This might be more readable if we did something like this. Now I'm wondering if you can get the both maxes at the same time. Why can't I just put this if statement into here? Now I think it's because we don't know what the actual max is until we look through the whole array. But let's see. Yeah, we don't know what the actual max is until you look through the whole array. So we could have also used the function to make this more readable. I knew it. The heap-based way is the only way you get sub n squared time. Approach one founder, remove the maximum stones in linear time, and add the new stone in constant time. I didn't know you could have it in an array. Define function last stone weight heap equal new max heap. Add all stones to heap while heap contains more than one stone. Get both heavy stones, smash them together, and then add the new stone to the heap. Interesting. So let's try the next problem. Special array X. Special array with X elements greater than or equal to X. You are given an array nums of non-negative integers. You are given an array nums of non-negative integers. Nums is considered special. You are given an array nums of positive only integers. Nums, oh, non-negative. I see. So 0 is possible. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Notice that x does not have to be an element in nums. Return x if the array is special, otherwise return -1. Can be proven that if nums is special, value is unique. Value for x is unique. So an example, when you have num 3, 5, nums is special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Return x if the array is special, otherwise return -1. can be proven that if nums is special, the value for x is unique. There are two values, 3 and 5, that are greater than or equal to. Nums 0, 0. Feels like the search range is. It feels like the search range is 0 to the largest number in nums, and if we go in reverse, we can just count how many numbers we are that have been larger. Right, so we'd have, for example, for this one, sorted, they would already stay the same. We started 5. We'd say how many numbers are bigger than 5. 0. We'd say increment larger than. Right, we'd have 1. We'd say, okay. How many values? Nums that are greater than or equal to x. My issue is, when do we stop then? We don't know what the value of x should be. Return x if the array is special, but the array is only special if there are exactly x numbers and nums that are greater than exists a number x such that there are exactly x numbers and nums that are greater than or equal to x. If we sort example 3, we get 0, 0, 3, 4, 4. 4 would be one number. Then we'd go to the next 4, which would be, okay, we have two numbers that are large. My question is, why isn't the answer 3? Why can't the answer be 2? Because there are also two numbers that are greater than or equal to 4. So I'm not understanding the question. We're given an array nums of non-negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers and nums. That are greater than or equal to x. How many numbers are greater than or equal to 2? There are 3. How many numbers are greater than or equal to 3? 3. So it looks like our stopping case is when the numbers count greater than is equal to the number at the indice. So we'll just say return -1. We'll say nums.sort a, comma b, and we'll sort it in ascending order. We'll say let I equal 0, I is less up, I is equal to nums.length -1, I is greater than or equal to 0, I minus minus. We're gonna have a value called let. It looks like we actually don't even need to keep track. Looks like we're basically just saying if num sub I is equal to, right, nums.length minus I, right, because we'd be at 0, 1, 2, 3, 4, 0, 1, 2, index 2 would be 2. So once we get to index 2, if the array length is 5, right, if num sub I, which is 0, 1, 2 equal to nums.length, right, -1 minus I, then we'll just return nums sub I. Oh, right, but the number, right, the actual, my bad, the actual range is going to be us starting at nums sub nums dot length minus 1, the last number in nums, and then stopping at 0. So our possible range of values would be from 5, 4, 3, 2, 1. Which means for this third case here, the sorted array would be 0, 0, 3, 4, 4, right? We'd start at 4, and we'd say, okay, num sub I and it's not about num sub I, it's if I which is equal to 4 to start, if I, right, because the ideal answer here is 3, I here is going to be 3. If I is equal to nums.length So to start, we start at 4. We'd say nums.length, which is equal to 5. 5 minus 4 gives you 1, and 1 does not equal 4. Eventually, we get to 3, and we say does 3 equal 5 minus 3 plus 1. And then we have 3, 5. Our range would be 5 going to 0. I would be equal to 5. I would be equal to 5. Does 5 equal 5 minus I, which is 5? No. Well, this is equal to nums.length. No, nums.length, which is 2 minus I. It doesn't. So then we're going to go to index 0. Does 0? No, we're going to go to 4. Does 4 equal nums.length, which is 2 minus 4, which is negative 2 plus 1? It doesn't. Does 3 equal 2 minus I? 2 minus I plus 1. 2 equals 0. This is a strange problem. Notice that x does not have to be an element in nums. Return x if the array is special, otherwise return -1. An easier way, I know we can get an answer like this where we don't have to sort. We'll just go for const num of nums, and we'll say we'll have a map, right? And we'll say we'll create a new map. It's going to map a number to number of numbers which are greater or equal to it, and we'll say if num is greater than or equal to I, map dot. First we get the value right. If map dot has a value for I, right, then we're going to get the value for I. Otherwise, we're going to get set the value to 0, and then we'll say map dot set I to value +1. Down here, we can just get before const num and count greater than num of map. We'll say if num equals count greater than num, return num. Yeah, our map is definitely broken. Our map should have a value range from 8 to 0, yet it only has 1 and 0. Oh, I don't know that oh man, we do have to sort. I don't know that the actual value in num, in the last value in nums is the largest value. So I'm actually just, we don't have to sort it because that would take n log n, but we could just get, we could set equal to -infinity, and then we'll just say for const num of nums max value is equal to map.max of max value and num. Then from here Now I see why the last algorithm probably didn't work. No, we were sorting then, so it didn't matter. We'll just set equal to max value. Okay, so the runtime, I mean, it's always variable, but we do linear iteration to get the max value. We're not using any, well, we are using space because we're using the map, and the range of the space is finite, I guess, since we at max take up 1,000 unique spaces in the map. How many numbers are bigger than it? Worst case, max value could be equal to the length of nums, for then we would do n squared operations. But it could also be greater than nums. We could do another version where we sort the array and then do n binary searches. Well, what if we just sort the array and count from reverse? If we just sort the array and count in reverse. I think that's what we tried to do. Then we could just check if there's any number Well, that's basically what we did, but I don't know what the time complexity of that is. I don't understand. We sort the array with reverse equals true. Well, they're sorting it in decreasing order. We'll say, well, oh, if you sort it in decreasing order, that's clever. You can say, while I is less than the length of nums and num sub I let's just say num sub I is 4 is greater than I plus equals 1. And then as soon as num sub I is not greater than I, oh, we're using a count array. The range is from 0 to 5, and they're just going to count the number of occurrences for every letter, for every number. And then as we iterate through the array, if we ever find a number, right, we keep the sum of the occurrences. We can just return that number when we get to that value. And that's really clever. The way to do that is just set up the count array, or you could use a map. And I think our answer is actually similar to that. We set up actually, how do they know what the max element can be in the count? I guess they don't, they just say count sub x. If element is greater than, or if the element is greater than or equal to x, count sub x plus plus. So they're saying x is equal to the number length of the array. creating a counts array, why are we setting x equal to nums.length? If we set x equal to nums.length, that's okay. So the value of x can at most be nums.length. No, that's just used as where to put the numbers in. Putting the numbers in reverse. We look through every element of nums. If element is greater than or equal to x, and counts of x, the numbers that are greater than element one. Else counts sub element plus plus. Where in I equals counts.length minus 1, I is greater than 0, I minus minus. The range is from 1 to the greatest value in nums. The way we can reuse that logic here we have to do potentially worse than n squared time. Over the max value, I is greater than or equal to 0. The solution to this one is so... I get why my solution works. I don't understand why everyone else's solution works. Well, maybe we'll find a better solution. Maybe we'll figure out a better solution when the problems become more restrictive, because you could solve this one without linear time. I mean, in worse time. So maybe when we have to do that, we'll be able to go a little bit deeper, but it seems fine for now.